Okay, so we're going to finish up solving oblique triangles, or triangles that don't have a 90, by using the law of cosines. Okay, we're not going to do this one right now. I just want you to look at it and tell me what would go wrong here if you tried to use law of sines. What's wrong? Mercedes?
There's not a full row.
You don't have a full row. Okay? So anytime you use law of sines, how many rows do you have to use? You have to pick 2. So the problem would be you need to pick 2 rows, but you can only be missing one thing. Well, if you pick the first 2 rows, you're missing alpha and beta. If you went with the second 2 rows, you're missing beta and c. And if you pick the first and the third row, you're missing c and alpha. So no matter how you pick 2 rows, you'd always have 2 variables when you set up your proportion. And that won't work. You can only have 1 variable. Okay, so this one, not one we could solve with law of sines. So the last 2 types of triangles that we can solve are side angle side, which the problem I just gave you up above is side angle side, and side side side. Both of these cases always have, the problems I'm going to give you will always have one solution. Okay? Side angle side is guaranteed always one solution no matter what, any type of problem you solve. And side side side, I'm going to give you ones on the test that have one solution. Can anybody think of a side 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 problem that would be a no solution? Like, what has to be true about the sides in a triangle? Do you know?
2 have to add up to be bigger than 1.
Right. Any 2 have to add up to be bigger than the third. So if I gave you a side side side, and I said this, could that be a problem you would be able to solve? No. Okay, I'm not going to give you one like that on the test anyway. All the side 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 problems will be solvable. Okay, so don't write no solution for anything with side 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 or side angle side. All right, so just like the law of sines, the law of cosines, there's really like 3 parts to it. Or in this one, it's really 3 formulas. Each formula follows exactly the same pattern. Okay, and if I show you the beginning of the first formula, I think you'll probably recognize what it is. Okay, what is that? Yeah, it looks like the Pythagorean theorem. And if we were going to go through a proof of the law of cosines, we would use the Pythagorean theorem to do it. We don't go through the proof of this one because there's some things in the proof that that come up that we don't know how to do. So that's why we're not going to go through the proof. Okay. So your sides are going to be A, B, and C, and your angles are going to be alpha, beta, and gamma, just like always. So it starts out C squared equals A squared plus B squared minus 2 times the letters that came before it. 2AB. Okay, that's the next part. And then the last part is the cosine of the angle that's across from the letter you started with. So what angle is across from C? Gamma. Okay, and that's the law of cosines. Okay. What's that? Perhaps. So the idea in general is that one side squared equals the sum of the other 2 minus twice the other 2 times the cosine of the angle across from what you started with. In the way that I just said it, you can start with any letter. You can start with C and write it. You can start with A, or you can start with B. Okay, so let's look at the version that starts with B. Okay, what would this one be? It would start out B squared equals, you know?
C squared minus A squared.
Keep all the signs the same as what's up above. Everything's going to stay the same except letters are going to move around.
C squared plus A squared.
Yeah, or you could say a squared plus c squared. They just put it in alphabetical order. So one side squared equals the sum of the other two minus 2 times, yeah,
AC cosine
yeah, 2ac, because a and c were the letters before it, and then cosine of the angle across from what you started with, beta. Right. These aren't different laws, they're the same laws. Okay, I'm just rewriting it all 3 ways. But you know, if you write it one way, you have all 3. It's follow the same pattern. Okay, and how about the last one? It would be a squared equals, yeah, cosine alpha. Okay, so that's the law of cosines, whichever version of it you need to use. Okay, sometimes you have a choice which one you can use first, sometimes you don't. Depends on the problem. Now, if we just look at the first one, okay, forget about the other 2 for a second. If we were doing this with a right triangle, what would gamma be? It would be 90. Okay, so this part, just watch. If you fill in a 90, okay, pretending like this was a right triangle, watch what happens to this formula. Okay, I'm going to take the cosine of 90, and I get 0. And then what would 0 times 2ab come out to? It would be 0. It doesn't matter what a and b are. 0 times anything is 0. And then if you subtract 0, well, what does that do? Yeah. So basically, if gamma is 90, that part disappears, and you just get back the regular Pythagorean theorem. When this angle is not 90, then this part will not be 0. It'll come out to something different. Okay. So technically, when you did Pythagorean theorem, this part was always here. You never saw it, you never needed to know about it, because that angle was always a 90. Now it's not. Okay. As far as angles, all the angles still add up to 180. And that's all we really need to know. So now we'll just look at some examples. Okay. Questions on the formula? Okay. So this is the one that I think I had up at the very beginning. Yep. So we're gonna solve this one. Okay, so now the first step would be to look at it and determine, should we try law of sines or law of cosines? It's not a huge deal other than wasting time if you try the wrong law, because you're going to get stuck very quickly. You can end up with too many letters. Gabe?
Is it possible for these problems to have multiple answers and no solution?
No.
No?
No.
These are all just one answers?
These are all one solution. Yep. Okay, so based on the table, or if you don't understand the table, you can always draw the picture. I think let's just try to look at the table. What law should I use to solve this? Yeah, you've got to use law of cosines. How come? Yeah, Josh?
There's no completed row.
Yeah, there's no completed row. Okay, now I want to be a little more specific. Out of the 3 versions of the law of cosines, okay, we'll call them version 1, 2, and 3. I have to use one of them here. Which one do I have to use? Okay? I have to use the first one, okay, because I'm already missing C. Okay, so if you look at all these formulas, every formula has a C in it somewhere. So if you're already missing C, you can't be missing anything else. So you've got to use the version where you can fill the A, the B, the A, the B, and gamma, we know. Okay, so we're going to fill everything into version 1, and then solve it.
So you can't use like the other formulas to find alpha and beta. So when you proceed.
Like the law of sines?
Yeah.
Nope.
Cosines.
Law of sines won't work here. You might be able to do something else after we figure out C. But I'll talk about that once we get there. All right, so the first thing we have to figure out is C. And then once you figure out C, you will have a row that's complete. But I'll come back to that. And when I come back to it, it's going to be easier if I have a picture. So I'm going to make the picture now. There's A, alpha, B, beta, and that would be C and gamma. So this is a side angle side problem. All right, so now let's set it up and solve for C. So we've got C squared equals the other two sides squared and then added together. And eventually I'll do some of these steps before I write them down. Like I could do 4 plus 9 and just write the answer. It'd save a little bit of work. But we'll come back to that. So minus 2 times 2 times 3. It's 2ab. And then that's multiplied by the cosine of 60.
Isn't that in parentheses though?
It doesn't matter because PEMDAS, you would always do multiplication before subtraction anyway. So you don't have to put parentheses. It's up to you. But if you want, you can, sure. All right, so now let's take a look, make it a little bigger. All right, so 2 squared gives me 4, 3 squared is 9. What's 4 plus 9? So 13 minus, what's 2 times 2 times 3? 12. Cosine 60. Now here, sometimes I put parentheses just to remind people what they should do first. But if you follow PEMDAS, you would do the right thing anyway. What would be my next step here? Yep.
Would you figure out what 12 cosine 60 is?
Yes, you have to do the multiplication before you can do subtraction. You cannot do 13 minus 12. Because the 12 is multiplied by cosine 60. Okay, so let's do that out. So the cosine of 60 is a half. So I have half times 12. So I get 13 minus 6. And 13 minus 6 is 7. So then C, how would I get C by itself? Just take the square root. And I'll just use my calculator. 2.646. Every problem on the test is going to be rounded, so we might as well just keep doing it the way you'll have to do it tomorrow. Yeah, don't leave it as a root. Yeah, we'll do it out. Good. And that's C, 2.646. Okay. Any questions on how we got C? And some of these steps, we could have shortened it up a little bit. Like we probably could have gone right to this step right away if we did 4 plus 9 in our head. But it's up to you. You can show that step out, or you can just go right to the second step.
So if we do this wrong, does that mean we get the whole problem wrong?
For this particular one, yes. If you make a mistake on C, you would get alpha and beta wrong. On the next one we're going to do, no. You can actually find everything separate, so you could get 1 out of 3 parts right, 2 out of 3 parts, or 3 out of 3 parts. So this one is all or nothing. If you get C wrong, you get it all wrong. But the next type, nope. You can get 1 wrong and still get everything else right. Okay, so I'm going to label where that C goes in this picture. Okay, and then I'm going to ask you, besides side angle side, what kind of problem it is now.
Now that you have C, could you switch back to law of sines if you have a full row?
Okay, well, let's look at the picture and see. Okay, that's a good question. Besides side angle side, what kind of problem is it now? It is a side angle, however you want to look at it. You know 2 sides and an angle. What other type? It's also side. You know all 3 sides. If we look at it as a side or side angle side, what law would you use? we do law of cosines again. What about side-side angle? What law would that be?
Fine.
That would be the law of sines. Now, would we want to use the law of sines with this one? Why not? I don't mind the law of sines most of the time, but I do with this one. Yep. This is the one where you get the 2 solution, 1 solution, no solution. So if you switch back to law of sines in the middle of the problem, then you're going to have to do all that stuff where you check for the second answer. If you just do law of cosines one more time, it will give you the right answer automatically. So I would stay away from using law of sines to finish the problem. It can be done correctly, but sometimes people make a mistake with it. So I would just stick with law of cosines. Now, really, we only have to do law of cosines one more time. Because once we get one of these angles, we can just add them up and subtract from 180. Okay? It doesn't really matter, because if we got C wrong, we already have everything wrong anyway. So what I would do is just do law of cosines once, and then add to 180, or subtract from 180. Okay, since we know all 3 sides, if you go back and look at your formulas, you know everything in every version right up to that dotted line. You could fill everything in. So we can pick which formula we want to use. So do we want to use, let's see, we need to solve for alpha and beta. So do we want to do alpha or beta? Beta. Okay, so that's the one that starts out b squared. Okay, it's easier if you have your problem in front of you and the formula, so you don't have to keep scrolling up and down, but I can't really do that here. So it starts out b squared, and let's write it as we go. Okay, what's b squared? You get 9 equals a squared plus c squared. What's a squared? 4. And c squared I have from the work I just did in the last problem. C squared is 7. So it's b squared, a squared plus c squared minus 2 times what 2 letters? 2ac. Okay, well, 2a, I can do that. What's 2 times 2? 4, but then I need to multiply by c. It's 2ac. So it's 4 times 2.646. Now we're using a number that's rounded, but it's rounded to 3 decimal places. So that's pretty accurate. Okay, 10.584. So I did that whole step out. Any question on how I got 10.584?
Why is it 4?
Why is it a 4?
No, why did you 4 times?
So you have to do this. So a is 2. So 2 times 2 gives me the 4
Yeah.
times 2.6.
Oh,
So that's why it's 4, just because a is 2.
okay.
Okay, so we got b squared, a squared, c squared, 2ac, cosine of beta, and that's what we're finding. So before we even solve it, what's going to happen in the very end of this problem? Inverse, we're going to have to do inverse cosine at the last step. Okay. Okay, anything I can combine together before I start moving things to the other side? Yep, I can combine 4 and 7. What's 4 plus 7? 11. Okay, and now I want to be careful. What would my next step be? We're actually going to leave the cosine on the right. We're going to move everything else to the left. Divide.
Inverse cosine.
All right, let me put up a different equation. What if that was your equation? You'd move the 11. this equation and the one above it are the exact same thing. The only difference is, well, there is no difference. It's 9 equals 11 minus 10 times something you don't know. 9 equals 11 minus 10 times something you don't know. So you have to move the 11, and then you can move the negative 10. Okay? So how would you move the 11 to the other side? I'm going to subtract it. And 9 minus 11 gives me negative 2. And now I can move the negative 10 to the other side by, now I can divide. Yep. And what would I divide each side by? Yep, negative 10.584. And I'm not even going to do that out. I'm just going to leave it as what we just wrote. What's on the right-hand side now? Yep. Now, this time I'll write it in 2 steps. Okay, so on the right is cosine. On the left, might as well cancel those out because it's a negative over a negative. And now we need the inverse cosine of this number. Okay, one thing I check before I do inverse cosine is I make sure this number in the bottom is bigger than the number in the top. Because if it's not, don't even bother doing the inverse cosine. It won't work. Something's wrong. The number in the bottom always has to be bigger than the number in the top. Always. Okay. And in this case, it definitely is. So let's see what we got. We get 2, actually, inverse cosine of 2 divided by 10.584. Okay. Because we've been doing sine all week, some people make a mistake here and they do inverse sine. Okay. Just remember, now it's inverse cosine.
Why is it plus? Positive 2 and positive 10.5?
Because I had a negative divided by a negative. So I made it a positive. You don't have to. You could leave it as negative 2 over negative 10, but it's just going to cancel anyway. Yep. Okay, so beta is 79.108. And that's beta. 79.108. Okay, and now that we've got 2 out of 3 of the angles, what can I do here? Yeah, take 79.108 and take the 60, and then just subtract from 180. So alpha is 240 degrees. Clearly I typed something wrong. 79.108, and then add that to 180. So 40.892. Okay, if you have extra time, or you just find the law of cosines fun, you could do the law of cosines again to find alpha and double check that you get it right. But most likely you won't have enough time to do everything 2 different ways. So if you're running out of time, I would do it the way we just did it. Okay, and that's a side angle side problem. So side angle side is actually harder than side 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 because it has 2 different types in it. The first type of equation you did is the one where the variable is by itself, pretty much already. Okay, it's on the left. And all you have to do at the end is take a square root. Okay. The other kind of equation it had in it is where the variable is on the right. And it's inside the trig function. Okay, and you have to end with an inverse cosine. Those are the 2 types of things that can come up. And that's it. So when we do side, 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 it's going to be one of these. Nothing new is going to come up. And in fact, it's only going to be one of these. It's either going to be this type or this type. It's not going to be both types like it was in this problem. Okay. What type is it going to be when you're doing side, side, side? What are you always solving for every time? You're always solving for an angle. So when we do side, 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 you're never going to be solving for a side. It's not going to be like this. It's always going to be like this. So there's the side, side, side. Okay, by looking at the table, it's probably one of the easiest ones to tell what type it is because you know all three sides, side, side, side. And you definitely don't have a row that's complete. Which row do we have that's complete?
That's a column.
That's what I was going to say. So yeah, we don't have a row that's complete. We do have a column, but columns don't count. So which version of the law of cosines do I have to use first? I can do whichever one I want. Okay? Because you know every side. Okay, so you can plug into any one of these that you want and find any angle that you want. But how many times do you have to do law of cosines at a minimum? At a minimum, you have to do it 2 times. But this is the kind of problem. You're going to find alpha, beta, and gamma all separate. So if you make a mistake on one, it doesn't have to mess up anything else unless you use it to find something else. I am going to use it to find something else because it's shorter. But if you don't and do law of cosines 3 times separate, you're finding everything separate. All right, so we did beta. Let's do alpha this time. Okay, just to try a different version of the law. Okay, so how does it start out to find alpha? Jamel?
16.
Yep, a squared. So 3 squared is 9. And then what comes after that? Yep, plus 6 squared. So we get a squared, b squared, c squared. Minus 2 times what times what? 2bc. We need to find that. So what's 2 times b? Times c? 36. Cosine, just look up at what you said you're going to do. You're finding alpha. Okay, so by doing some of that arithmetic beforehand, we really shorten the numbers. And what's nice with a side, side, side is they usually don't give you any decimals. So all the numbers we're going to work with in our problem are going to be whole numbers. Okay, what can I do here? Yep, you can always add the 9 and 36. You just combine like terms. Okay, somebody else tell me my next step. Say this.
You're going to subtract the 45.
Yep, I'm going to subtract 45. So we got 16 minus 45 is negative 29. And 2 steps left. That would be my second to last step. Yep, we're going to divide by negative 36. So I canceled the negatives on each side and the 36 on the other side. And again, don't worry what 29 divided by 36 is. Okay, in fact, we're never even going to do that out. Because I don't want to know what 29 over 36 is. I want to know what alpha is. So what am I going to do with 29 over 36? I'm going to take the inverse cosine of it. So take the inverse cosine of 29 over 36. Okay, so alpha is 36.336. We just did alpha. That was the calculation to find alpha. Now, what if this was an isosceles triangle? How could you, just in case something like that comes up. Okay. Let's say you just found this angle. Would you have to do law of cosines again? What could you do instead? Okay.
20 minus 36.336 divided by
Yeah, if you found the angle at the top, you'd have to draw it out and see which one you found. But if you found the one at the top, subtract it from 180, and whatever's left, divide it by 2 for the last two angles. Now, what if when you drew it out, you found the one at the bottom? What else would you automatically know? Yep, Miles?
So you can just pull it and find the bottom angles, and then subtract that from 180 and find the top angle.
So what would this one on the left be?
The same.
It'd be the same as the one on the right. So if you know one of them, you automatically know the other one, and then you could find the third one. Okay, so keep that in mind. If you have an isosceles triangle, you can finish this up a little shorter than using law of cosines. Here, do I have an isosceles triangle? No. How do I know that?
Choose this side and this side.
Yeah, all the sides are different. So I know all the angles are going to be different. Okay, so we did law of cosines for alpha, we did beta. I don't think we used the one that began with gamma, did we? Nope. Okay, so we'll finish up with finding gamma. Okay, and so I don't have to scroll up and down if somebody can just tell me. So that starts out c squared equals a squared plus b squared. What was c? 6, so I need to square it. What was a? So a was 4, we square it and get 16. And b was 3, so we square it, and we get 9. And then I need 2 times 4 times 3. Any question why it's 2 times 4 times 3? It's 2ab. Okay, so what's 2 times 4 times 3? 24. And then it's the cosine of gamma. Okay, so Dave, first thing I would do here? Yep, and what would you get? 25, and then what are you going to do with that 25? So I'm going to do all that at once. I'd combine the 16 and 9 and get 25. And I'm not even going to do that out. I'm just going to move that to the other side. Okay, and then my last step to get cosine gamma by itself would be, what do we do with the negative 24? Yep, we're going to divide this by negative 24. And what else are we going to do to it? We're going to take the inverse cosine. Okay, so if you do some of the steps for the law of cosines in your head, you really can shorten it a lot. You really shorten everything you write to 2 or 3 steps. If you want to write out every single step, that's fine too. But any questions here? Yep.
Could you make that like positive 24 and positive 25?
If you really wanted, I would just use your calculator and type that out. You could just do it out if you wanted. But what's going to happen is this is going to stay as a negative because 36 minus 25 is a positive divided by a negative. So I wouldn't try to do anything too fancy to switch it up. But that would mess up your answer. Yeah. All right, so let's just type it in exactly the way we see it. Inverse cosine. If you're not going to do out the 36 minus 25, which, I mean, it's easy enough. You just could do it out. You got to put it in parentheses. And then divide by negative 24. Close the parenthesis, and I think we're good. Okay, so we get 117 point, it rounds up to 28. Okay, 117.28. Okay, and now you could just take alpha and gamma, add them up, and subtract from 180. Okay, so we get minus 36.336 minus the 117, and we get 26.384. Okay, is the biggest side across from the biggest angle?
Yeah.
Yep. How about the smallest side with the smallest angle? Yep, so it looks It doesn't look like anything is obviously wrong. And that's a side, side, side. Any questions on the side, side, side? Okay, so side, 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 you have a little more freedom. You can pick any version of the formula, and you're going to use the inverse cosine twice. Side, angle, side, you have to use a certain version first. You've got to use the version for the angle they give you. And then from there, you have a choice after which one you want to use. All right, so the last problem we'll look at is a word problem. And what we're doing in this problem is basically trying to find the distance between 2 points. Okay, and there might be a reason why we just can't measure the distance directly. Maybe the 2 points, one's on one side of a cliff and one's on the other. So you got a house on one cliff, a house on the other cliff, and you want to know the distance between the two houses. Okay, so the way we're going to measure it is a surveyor is going to stand. Basically, let's pretend these are our two houses. Call them house 1 and house 2. And the surveyor is going to stand right there. Okay. And again, there's something between the houses that's preventing us from just measuring the distance directly, okay, whatever it happens to be. So the surveyor is going to measure a couple distances and an angle. So the surveyor is going to measure the angle. And I'm going to label this out with nice letters and stuff in a second. Okay. But he measures the angle between the two houses to be 70 degrees from where he's standing. Okay. It's a 70-degree angle. And then the surveyor can measure the distance to house 1 and the distance to house 2. Okay. And those distances come out to 50 feet and 70 feet. Okay, so all you really need to know is angle between the houses is 70. First distance is 50. Second distance is 70. That's all you need to know. Okay. How far apart are the houses? Okay, so I set this up kind of like a lot of the homework problems. I already have the diagram drawn for you. Okay, so we already have the diagram. So we've got our two houses. And the particular reason why this guy can't measure between the houses is because there's poisonous tree frogs. So that's what I came up with. And I wasn't able to find a picture of a surveyor, but I did find a German trench soldier. So there's our surveyor. What's the difference? All right, so I've labeled everything using the letters I had in the problem. Okay, our soldier or surveyor is able to walk off the distance to each house. Okay, he avoids the poisonous tree frogs by doing that. That's a good thing. And the distance to house A is 50 feet. And the distance to house B, 70 feet. And the surveyor is also able to get the angle from where they're standing to the two houses. Yep, that was 70 degrees. Okay, so the goal is to find the distance between the two houses. Find that dotted line. Okay, what kind of triangle do I have here? In terms of like the three letters.
Side angle side.
Yeah. It's a side angle side, which means it's which law? Cosines. But you don't have to find everything. I don't care about the other two angles. All I care about is that side. Okay, so you just have to do one calculation. Okay, numbers are going to get a little big when we square them, but just use your calculator. Okay, so how would the formula start out? Okay, and how about using the numbers I have? What would you plug in? What would you plug in?
Or 70 meters.
We don't have anything labeled A, B, or C, so we can't really go by the exact letters, but you have to go by the general idea. One side squared equals the sum of the other two squared. So what's the first side you would square? Yep. You always square the side that's across from the angle that you know. Okay, so one side squared equals the sum of the other two minus what? Came out?
3 times 50 times 7.
Yeah, minus the two sides you just wrote down right before it. So 2, 50, 70. And then lastly, times the cosine of 70. Cosine of the angle across from the side you didn't know. And this is the type where the letter is pretty much by itself, so you're not going to need inverse cosine. You just have to do all that out and see what you get. All right, some of this we can do. What's 50 squared? 2,500. And then 70 squared? 4,900. And then 2 times 50? That's 100. And what's 100 times 70? 7,000. Okay, and I think we've, actually there's one more thing we can do still. What's 2,500 plus 4,900? Yep, 7,400. And now I think we've reached the point we need a calculator. Okay, what would I do next? The subtraction or multiplication? So right, we have to do the cosine 70 times 7,000. You can't do 7,400 minus 7,000. Okay, we'll have to do the subtraction at the very end. Okay. So type 7,000 cosine 70. Cosine 70. We get 2,300 and let's just say 94. 2,394. Okay, since we're measuring the distance between houses, it's probably accurate enough if we were to the nearest foot, but the directions in the problem would say round to whatever. Okay, now we can do the subtraction. 7,400 minus 2,394. And how would I finish that up? Take the square root of 5,006. Okay, so the distance between the houses is about 71 feet. Roughly. Okay, so any questions on that? Okay, so on the test, there will only be one word problem. It's not going to be both law of sines and cosines. I'm going to pick one and just one word problem. Okay. Okay, so homework tonight's on 274. And it's 9, 11, 13, 17, 25, and 27. Okay, on the test tomorrow, there will be 5 questions. Actually, probably 6. There'll be 6 questions and a bonus question. Okay, you're going to have one of every type we've done. And keep in mind any shortcuts I mentioned today, like if you had a scalene or isosceles or equilateral, you might be able to solve the problem a little quicker.